Hey guys, in sticking with our theme of pieces and parts of triangles, we're going to talk a bit more of some of these different parts of triangles and how they interact and certain pieces of congruency that we'll see come about. So the first thing we're looking at is a term we should already know, perpendicular bisector. So those two words in themselves should mean something to you. So perpendicular means meeting at a right angle. Bisector means cutting it in half. We know this construction already, so I'm just going to sketch it up here. If you want to go through this construction again, let me know in class, and I'm happy to do that for you. So perpendicular bisector is a line, ray, or segment that bisects a segment. Line, ray, or segment that bisects a segment. So I could draw a line right down the middle, and I'm not using my straight edge, please use yours, that meets at a right angle where both sides are congruent to each other. Again, we can go over this construction if you want, just let me know. Okay, so here's our theorem to go with this. Perpendicular bisector theorem says in a plane, if a point is on the perpendicular bisector of a segment, then it is the same distance from the endpoints of the segment, or equidistant from the endpoints of the segment. So if CP is on the perpendicular bisector of AB, then the length of CA is equal to the length of CB. The converse of that says, in a plane, if a point is equidistant from the endpoints of the segment, then it's going to lie on the perpendicular bisector of the segment. So if we know that DA is equal to DB, then we know that point D lies on the perpendicular bisector of segment AB, meaning it meets at a right angle and it's the same distance. So if we extended this line and point D went through there. Okay, so if we know that AC is the perpendicular bisector of BD, so it's meeting at a right angle, these two pieces are the same, then by our perpendicular bisector theorem, we know then that AB and AD are going to equal the same length, so we can set those two expressions equal to each other and solve. So I'm going to subtract 7x from both sides. So negative 6 equals negative 3x. I'm going to divide by negative 3 on both sides. So 2 equals x. It's not what it asked for, though. It wants to know the length of AD. So I'm going to plug that in. AD is equal to 4x, or 4 times 2. So AD is 8 in this case. Okay, so in the diagram, KN is the perpendicular bisector of JL. What segment lengths in the diagram are equal? Okay, well, if it's the perpendicular bisector, then we know that JL is cut in half. So we know that JN would be equal to LN. We also know then that the segments going up to point K should be equal to each other. So JK would be equal to LK. We also see from the picture that JM is equal to LM. Is M on line KN? So what you need to look at is are the segments going to point M the same length? And since they are, we can say yes. Okay, so the concurrency of perpendicular bisectors of a triangle. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. So if PD, PE, and PF are all perpendicular bisectors, then we know that PA is equal to PB, which is equal to PC. And this point P has a special term, and it is called the circumcenter. That's a term that you need to know. Circumcenter. Okay, so the last piece here, you can go ahead and look at, but we're not going to do on our notes, we'll do in class together. It says 3 friends are playing catch. You want to join and position yourself so that you are the same distance from your friends. Find a location for you to stand. Okay, so we want to be the same distance from the vertex. We're going to find that circumcenter. We're going to do that through construction. So think through how you could do that, and then in class we will go through this together. So if you have any questions, please come see me. I'll see you in class to finish up these notes.